In the early part of the 20th century, it was believed that the Milky Way galaxy was the universe. Faint fuzzy orange and spiral structures were observed, but until the distances to these objects were measured, it was assumed that they were small nebulae within our own galaxy. It was also thought that the universe was static and certainly not changing in size. In fact, Albert Einstein introduced a term, a fudge factor, into his equation for general relativity that would allow such a static universe to exist. When the following discovery was made, Einstein removed this term from his equation. In recent decades, discoveries have necessitated the return of this term, but for different reasons that will be discussed in Chapter 22. Beginning 1912, Vesto Slipher, an American astronomer, had measured nebulae with strangely redshifted spectra. In the early 1920s, Edwin Hubble and Milton Mason measured the distances to many of these nebulae, e.g. the Andromeda Nebula, and showed that these nebulae were much farther than previously thought. They were actually entire galaxies. Ultimately, thanks to these three astronomers, the universe was suddenly much bigger than previously thought, and it was expanding. Running the expansion backward in time, it was clear that the universe must have had a beginning. Shown are the spectra of galaxies at different distances. Hubble and Mason measured the distances using the Cepheid variable method discussed in Chapter 16. Pointed out in the spectra are the H and K lines of calcium. The arrows show the amount of shift in those lines toward the red end of the spectrum. Note that the more distant a galaxy, the greater its redshift. Thus, galaxies at greater distances are moving away from us with faster velocities. This is the original graph that Hubble published showing the relationship between a galaxy's recessional velocity away from us, and its distance. The graph clearly shows that the greater the distance, the greater the velocity. They also noted that their redshifts were proportional to their distances. Recessional velocity and distance have a simple linear relationship. For example, a galaxy 3 times farther away is moving away from us at 3 times the velocity. A galaxy 10 times farther away is moving away at 10 times the velocity, etc. This behavior also means that not only are galaxies moving away from us, they are moving away from each other. The universe is expanding. This result was in agreement with an existing model of an expanding universe that was based on Einstein's equation of general relativity, without the fudge factor. Measurements made since Hubble's publication continue to confirm this behavior, now called Hubble's law. Shown is still another graph of recessional velocity versus distance. As stated previously, the recessional velocity of a galaxy is proportional to its distance. The proportionality constant in the equation, written as h0, is called the Hubble constant or the Hubble parameter. Graphically, it is the slope of the line. The value of the Hubble constant is determined observationally using data about the measured velocities and distances. The more data we have, the better we can determine its value. Knowing the value is important because the Hubble constant is the expansion rate of the universe at the present time. The value of this constant is believed to have changed over time, but it is the same everywhere in the universe at any particular time. It not only tells us about the expansion of the universe, it also tells us about the age of the universe. The larger the value of the Hubble constant, the younger the calculated age of the universe. Based on current data, the value of the Hubble constant is 67.80 kilometers per second per megaparsec, and the age of the universe is 13.8 billion years. The Hubble law is now used as a tool to measure distances to galaxies. To do this, the redshift of a galaxy is measured and its recessional velocity is calculated in units of kilometers per second. That velocity is then plugged into the equation to give us the distance in megaparsecs.